Topics and Math Notes, Chapter 3, Rotations around the origin. Rotate the polygon around the origin. Alright, so let's graph the original coordinates. Alright, so there we have it. A is 1, 1, B is 4, 1, and C is 1, 5. So next, we're going to rotate the polygon 90 degrees, 180 degrees, 270, and 360 counterclockwise. So counterclockwise will be going this direction. Okay, so sometimes it's easiest to kind of move your paper. So if you think of A as 1, 1, and we turn our paper sideways, now it's negative 1, 1. Okay, C, instead of being 1, 5, it's going to be negative 5, 1. And B, instead of being 4, 1, it's going to be negative 1, 4. Alright, so go ahead and connect those, and then we're going to try to do the original one, 180 degrees. Alright, also write the coordinates of the A prime, B prime, C prime. So let's move on to rotating the blue triangle ABC 180 degrees. So again, sometimes it's helpful to move your paper. So if we think of A as the point 1, 1, and then turn your paper upside down and go to the point 1, 1, we'll have our first value. Okay. B, think of that as the point 4, 1. Turn your paper upside down and go 4, 1. So it ends up being the point negative 4, negative 1. C is the point 1, 5. Turn your paper upside down and go the point 1, 5. And there you've got it. Go ahead and let's think about the coordinates there. So the A, you could label it A double prime if you wanted, would be negative 1, negative 1. Okay? B would be negative 4, negative 1. And C would be negative 1, negative 5. Alright, let's go 270 degrees. Alright, so rotated 270 degrees. Another way to think about it is it's just clockwise 90 degrees. And we'll talk about the negative degrees here in a little bit. But let's come up with the new coordinates. Alright, so your A prime would end up, or A prime prime prime, would end up being 1, negative 1. Okay, B would be 1, negative 4. And C would be 5, negative 1. Okay, and finally, if we wanted to rotate this, the blue triangle ABC 360 degrees, that's just going to get us back to the original. So if we wanted to put a line over the original triangle, if it says rotate it 180 degrees, that's just going to be the same image. Alright, so what did these coordinates do to the original? So let's think about that. If we look at our original coordinates for the 90 degrees, 1, 1 is kind of a hard coordinate to look at because you don't know if they switch spots or change signs or what. But maybe focus in on the 4, 1. So 4, 1, and for 90 degrees it was negative 1, 4. Alright, so notice what happened there. They switched spots, and then the old y changed to the opposite sign. So down here, we say the reflection, so capital R, of 90 degrees of any matrix, any coordinates, x, y, is going to result in switching spots and making that original y negative. Okay? The reflection for 180 degrees, what happens here? So on 180 degrees, these are staying in the same spot, 4, 1. It's still 4, 1, but they both change signs. So reflection across 180 degrees just made them both be negative. Stays in the same order, x, y, but make them negative. Okay, 270 degrees. Let's look at what happened here. So they switched spots. Instead of 4, 1, it's 1, negative 4. And then the original x changed to negative. And then finally, 360 gave us the original. Okay, so that one is the same. All right, we want to come up with a 90 degrees rotation, the 180 degrees rotation, 270, and 360. So if I rotated this 90 degrees, what would I get? So remember, we said if we're rotating it 90 degrees, the coordinates are going to switch spots, and then the original y will change to negative. So I'm just changing my y's to negative and then switching spots with the coordinates. So if I think of my original was 6, 2, 4, 3, and 1, 2. Go ahead and connect those and plot out your new points. All right, so there's our original in the 90 degree rotation. What would the 180 degree rotation be? So remember, you're going to do capital R, and what's going to happen? So go back up and think what happened when we rotated 180 degrees. The x and y stay put, but they just change to the opposite sign. So go back to the original here, always looking at the original. So they're going to stay in the same spots, but both change to negative. All right, try the last one. Rotate 270 degrees. I guess this isn't the last one, but the next one. All right, and finally, if we do 270 degrees, what happens with 270 degrees? So we're going to switch our x and y around, but our original x is going to change to negative. So it's going to be negative 6, 2, or 2, negative 6, 3, negative 4, and 2, negative 1. And then you have your 270 degrees rotation. The last one wants us to rotate it 360 degrees, but think about yourself. If you do a 360 degree rotation, you're just going to be back to where you started. So if we did a 360 degree rotation, we said it'd just be back to the original graph. So if I wanted to plot out those points or write up those points, the 360 degrees rotation would just be back to the original. Okay? All right, go ahead and pause the video and try example 3. All right, go ahead and check your answers. So they should look like they're all overlapping too when you look at the graph. So just be really precise on which one should be negative, which one should be positive. Okay, can we rotate more than 360 degrees? So if we went the whole way around and then some, what we could do is take 450 minus 360. So 450 degree rotation would be the same as a 90 degree rotation. Okay, 540, so just, it's like we're going all the way around the circle and then an extra how much degrees. So we can take 540 minus 360. So we're just subtracting 360 from each of these to see where they would be, how many rotations it would be. Because we know it's a whole time around, and then how much more. So 540 would be the same as 180. 630 would be the same as 270. And 720 would just be a complete 2 circles. So once and then twice. Right back at the same spot you started. Okay. What if we wanted to go the other way? So if we wanted to rotate negative 90 degrees, that's going to be a clockwise rotation. So if we think about an object in this first quadrant and we rotate it clockwise, that's the same thing as a 270 degree rotation. So negative 90 would be the same as 270. Negative 180 would be the same thing as 180 degrees. Negative 270, now we're going like 3 quadrants away there. So it's going to be the same as a 90 degree counterclockwise rotation. And 360, negative 360 is right back where you started. So that's the same thing as a 360 rotation. Also the same thing as a 0 degree rotation. Okay, we want to rotate the following coordinates: negative 90 degrees, 180 degrees, negative 180, and negative 270. So we're going to write it out like this. The rotation of negative 90 degrees equals what? I'll use a different color here. What would be the rotation of negative 180 degrees? And finally, the rotation of negative 270 degrees. So we said rotating 90 degrees was the same thing as rotating, negative 90 was the same thing as rotating 270. So if we can think of what did we do for that 270 degree rotation? So we flip the coordinates and then the original x changed signs. So we flip the coordinates, that will become positive 3. Flip the coordinates, that will become negative 2. Flip the coordinates, that will become negative 1. There we go. Okay, so let's go ahead and plot out our original. And then if I wanted to rotate this 90 degrees, negative 90 degrees clockwise, so 90 degrees clockwise or 270 degrees counterclockwise. Hopefully the coordinates that we wrote out make it work, make it look like it's 90 degrees clockwise rotation or 270 degrees counterclockwise. All right, if we look at the red image, we can see that that was a rotation of negative 180 degrees. So from our original triangle that's with the black pin there, we flipped it completely around 180 degrees to get to the red one. Okay, finally we want to rotate negative 270 degrees. So we're going to flip the coordinates and then our original y will become positive. So go ahead and graph that one out. What does that look like? All right, so we can see the rotation matrix for negative 270 degrees, which would be 3, negative 3, 2, 2, and negative 4, 1. All right, you can go ahead and get started with the homework.